This is Differential Equations, section 1.5, activity 1.5.3. This should be our last video for this section. So in this problem, we've got let's pretend that you are a new parent and you're going to set up a college fund for your kid so that when it's time for them to go to college, they might have hopefully an easier time paying for it than you are currently right now. That would be really kind of you to do. Now, we're going to deal with this in this problem. T will be in units of years. So last time T was in minutes, it's now in years because financially, interest rates are per year, and these parents are contributing $2,000 per year. So what we're going to do is we're going to set up the differential equation. So let's let capital P stand for principal, or as the amount of money in this account. So what does this problem tell us about dp dt, the change in principal with respect to time? Well, if this were 0, then the money would stay completely constant. If it's positive, the money is increasing. If it's negative, the money is decreasing. So here, they're adding 4% of the 4% interest rate. So that's 0.04 times P. So that's your interest rate. And they're also contributing $2,000 per year, so plus 2,000. So each year, the amount goes up 2,000, and 4% of it what it already was. Okay, so now let's solve this. So here we want to write it in the form that we like best. So dp dt minus 0.04 P equals 2,000. So that makes our integrating factor equal to e to the integral of negative 0.04, just a constant, dt. So that's equal to e to the negative 0.04 t. And then if you don't like writing decimals, you could also write that as e to the negative t over 25, because 0.04 is 1/25. I don't know. I think I might stick with the decimal form, perhaps. Then that means that P of t equals 1 over this, so that'd be e to the positive 0.04 t times the integral of e to the negative 0.04 t times 2,000 dt. Well, that's not too bad of an integral. So that's equal to e to the 0.04 t times, actually, maybe the fraction is nicer. I don't know, because then I'm dividing. Yeah. So if I'd written it like a fraction, then it'd be like, oh, dividing by 0.04 is the same as multiplying by 25. See, that's nice. Fractions are better. So then, so integrating here would be e substitution, which means you divide by 0.04. This means you're multiplying by negative 25. So negative 25 times 2,000 times e to the negative 0.04 t plus c. Okay, so that's equal to c times e to the 0.04 t minus and then that's just a constant. So minus, so that times that becomes 1. 25 times 2,000 would be 50,000. So here, we know that the parents, the starting money would be 0, right? So that means in order for the starting money to be 0, if t is 0, you want this thing to be 0. And if t is 0, then e to the 0 is 1. So that means P of t equals C must be 50,000 then. 50,000 times e to the 0.04 t minus 50,000. Okay. So we solved the initial value problem. How much will be in the college fund when the child turns 18? Well, let's pull out our handy dandy calculator. Let's see, clear everything. So 50, 1, 2, 3, 50,000 times e to the, nope. It's been a while since I used a calculator like this. So let's do the exponent first. So 0.04 times t is 18. So that's 0.72. E to the power of that is 2 times 50, 1, 2, 3, equals that, minus 50,000 equals that. So you'd be left with 52,721. $7.21 and 66 cents. Okay. Now go back. What would they need to invest per year to have 80,000 in the college fund when the child turns 18? Well, we can do this. We could do it all over again with a variable instead of 2,000, or we can kind of track the 2,000 throughout this whole process. And so this right here, this number is 25 times 2,000. So really it's like 25 times your starting, your goal. Let's say the goal is G. So no, let's not overcomplicate it. So let's say your yearly payment. Can you use P because you're already using P for principal. So let's say P of T equals, instead of 50,000, it's 25 times yearly payment, which we could use with like capital Y. 25 Y times e to the 0.04 t minus 25 y. Okay. And I want this to equal 80,000 when t is 18. So then plugging in t is 18, I have 80,000 equals, I'll factor the y out, times 25 e to the 0.04 times 18 minus 25. Okay, so then divide that over, and you have y. So I'll state it here. Y equals 80 grand divided by 25 times e to the, did we already say 18 times 0.04 is 0.72? Sounds about right. 0.72 minus 1. Okay. So, handy dandy calculator. Hey, come back here. Clear. So then 0.04 times 18 is 0.72, just like we said. E to the power is that, minus 1 is that, times 25 is that. Now I want to take 1 over that is that times 80,000 is that. So contributing $3,034 and round up 81 cents. So equals $3,034 and 81 cents. There you go. That completes activity 153.